So awesome. Thank you so much. That's such a warm welcome. And hello to everybody at home or in your office. I hope wherever you are that you're having a fantastic day with all the awesome content today. I hope I'm going to add to that awesome content. Uh, as I was saying, Azure Functions is one of my favorite technologies. And this is really like an introduction, a guide to where you can get started and how you can use them to their best ability and just get going. So let's click on. I have had problems with my slides advancing, so I'll say that now. And my mouse is there. We go, finally. So that's me. I work at VMware, and people may go .NET at VMware. Yes, there's a lot of .NET at VMware. I'm a Microsoft MVP. I'm a GitHub star, and I also organize my local .NET community meetups. Now, this is the official word from the Microsoft website on Azure Functions. And they say, develop more efficiently with functions, an event-driven serverless compute platform that can also solve complex orchestration problems. Build and debug locally without additional setup, deploy and operate at scale in the cloud, and integrate services using triggers and bindings. So that's a lot of words. I'm hoping to show you all of those words because it's much easier. But a little bit of history. Azure Functions were released in March 2016, and you could only develop them on the Azure portal. You couldn't work with them locally. You couldn't collaborate. They were very different. You had some weird JSON type stuff to put your dependencies in, and there was no source control. It was all just not great. But now, since September 2018, we got Azure Functions 2.0, and that meant that you could develop locally, which was like, oh, this is amazing. And then in January 2020, we got Azure Functions 3, which was even better. We were using .NET Core 3 for that. And then we've had releases now in line with .NET releases. So you could use .NET 5 last year, and now you can use .NET 6. Now there are a few quirks with it, which will go in, but it supports more than just .NET languages as well. You can have Node, Python, Java, PowerShell. There are other languages that you can make work on Azure Functions. You just have to sort of do the runtimes yourself. So they are super flexible and allow you to choose the right language or tool for the job. Now, you may want to know why would you bother with functions? If you've got an application or something, why would you bother with functions? And we did touch on it in the intro with the guys. If you have business critical features that don't allow for a rewrite of your application, or you want to use the latest, I don't know, C# 10 language features, or this is like you just don't want to shoehorn it into your monolith. An Azure function is a really good use case. It can be a satellite to your main monolith. That's how I like to think of them. You'll have your main application working along, and you can take a key piece of functionality that's maybe quite expensive, and you can put that into an Azure function. It's also a nice way to start breaking up your monolith in a stage type way if you want to move more towards distributed systems. So you can start breaking bits of information out of your monolith without having to worry too much about the greater infrastructure, because a lot of that is managed by Azure Functions. So that's what I'm going to show you, a few different things of that sort. Okay. So see if I can get this to change. Now, how do Azure Functions actually work? Azure does a lot behind the scenes for you. I've recently been looking at the equivalent in GCP and AWS. And compared to the other two, Azure is doing a lot for you when you create these Azure functions. So it's really nice to appreciate how lucky we are with Azure Functions that we don't have to do a lot of boilerplate, like setting up API gateways or doing permissions. It's all handled for us. So let's think about what happens when I make an HTTP request to an HTTP function. Any function is called a trigger. We'll have a look at those in a minute, but let's consider the HTTP trigger. So I fire off a request. It comes into Azure. Azure goes, okay, this needs to go to, I'm going to sneeze. This needs to go to this particular function. So that is kept in Azure Storage. So it needs to go and find a server that has the capacity. And then it's like, okay, this function is going to run on this server. And then the server needs the function's runtime. So it has to do that. And then that starts. And then finally, it executes. Now, that can take quite a lot of time. I mean, when you're looking at requests, and that is called a cold start. Excuse me. However, Microsoft acknowledged that this was a cold start and it wasn't great. So they then did pre-warmed starts. So rather than going and finding a server and then allocating it and then putting the runtime on it, Azure has a pool of workers. So when you come along and make your request, it can go, okay, here is a server, it's ready, it's already got the functions runtime on it, let's start. So it does that, and your code will run much quicker. So that's called a warm start. And then, that's helped a lot. I wouldn't get caught up on that. I'm going to share a link later on how the difference in times we have with the cold start and the warm start and the hot start, which is always available. Now that would be more like your web app. Okay, so installation, getting, actually to start with Azure Functions. If you use Visual Studio or Rider, you're going to already have it available to you. You can just create a new project within your chosen IDE and choose Azure Functions. If you want to use the command line, you'll need the Azure CLI tools, and you'll need VS Code or an equivalent type code editor. You will need storage emulation. Now, remember I said that your function is stored in Azure Storage. When you develop locally, you'll need to emulate that. Now, with Visual Studio, you get the Azure Storage emulator, but if you are running on Mac or you're using VS Code, you're going to need to install one. And I recommend Azurite because Microsoft is phasing out the Azure Storage emulator and promoting Azurite. It's cross-platform and it does everything for you. And then the Azure Functions core tools, this is the CLI, and this also comes, this is how you can run locally. So develop and test your functions on your local computer. You can connect directly to Azure services, so you can deploy your functions straight to Azure. You may need the AZ CLI as well, but you can do it all from inside the Azure Functions core tools. And you can also debug locally with the full functions runtime. And this is what I really appreciate now after looking at the other cloud providers, that you can't, on AWS, you can't really debug locally. It's really difficult. With Google, it's a little bit easier, but nothing is quite as straightforward as Azure Functions. So we really need to say a well done for that. Okay, now I want to show you a demo first of just how quickly you can get started. So if we come over here, I'm hoping that this one's going to be big enough. This is just Visual Studio 2019, because I don't know about if I've got my 2020 on here, but it doesn't matter. It's very similar. So we'll go with your Azure Functions. Come on. We're just going to create that. I know that's a little bit small. We'll try and make it bigger once we get in it. And here we can see that you can choose your framework. Now in 2022, you'll have .NET 6, but I wanted to show you here because you can see we've got .NET Core 3 long-term support, and then we go to .NET 5 isolated. .NET 5 wasn't fully supported. You had to run it in an isolated form. But .NET 6, because it's LTS, will run both isolated and from within the platform. So that's really cool. So we have lots of different triggers here. This will just create an empty solution with no triggers. But there's things like service bus queue, HTTP trigger, open HTTP trigger with open API. So that's Swagger, which is awesome. That's quite new. Timers, queues, blobs, IoTs, events, Cosmos DB, SendGrid, Signaler, RabbitMQ, the list goes on. So we're just going to choose a straightforward HTTP trigger and create that. And eventually, here it comes. Ugh, why is this blue? Does anyone else have this problem? You have like your theme on your Visual Studio, and then you open it up the next day and it's in blue. I don't understand this. Deep breath. Okay, so this is our regular function it comes in. If we have a look at the Solution Explorer first, we can see we have a solution and then we have a function application within it, and it has some interesting things. We have local settings.json, and this is like our app settings on a standard web app. There's some interesting things around here, which I'll show you on a different application. But this is where you put all of your keys and such. Host JSON, you don't really need to worry about this. It will come with the template. You can update it, and you can update it when you deploy. And then we have our CS file, which is our function. So you have this decorator, and we can change that to Codecamp, for example. It doesn't matter what it's called. Let's come and have a look. And then you'll see we have HTTP trigger here. And that defines the type of trigger it is. We have the authorization level, and this is not in play when you develop locally. So you have a couple of options here: admin, anonymous, function, system, and user. As I said, it doesn't matter when we're developing locally. You can say what type of request this will accept. So this particular one's going to take a get and a post, and you can define a custom route. The default route is going to be localhost at the moment 7071/API/Codecamp now, but you could define that to be localhost/ Codecamp and take out the API. So that's what you would define here. And then we get a request in, and we get the logger. So that all comes in, and then they give you a few things here: how to get a value off the query or how to get it off the body. So if I just run this, we should see the emulator pop up. Give it a moment. You can see starting the Azure Storage emulator. And then we get into our command line here. And you can see here is our function. We got that localhost 7071/API/Codecamp. And we're going to test this out with Postman. I've probably already got one there. I do. So let's start with the get. Actually, I'm just going to delete that and we'll start again because it's easier. Okay, so if I drop that in and I just do a straight up request to it, you can see it's gone through and it says, oh, give me a name on the query string. So that in here is if it's null. Okay, so we hit that null. Let's go and give it a query name equals Layla. We do that. You can see it's pulled it off the request. Now, if I get rid of this and we do it as a post, we come in and we're going to send it some JSON So let's give it some valid JSON, and we'll go name, and let's go, I'll just go Romania, and send. Now you can see we've now got it off the body. So when you start with the template, there's a lot of building blocks just to get you started really easily. It holds your hand and takes you through the process. So I think that's really a lovely start. Just off the template, you can go and play and see how things go. Okay, so let's, yes, I'd like to stop debugging. Let's go back over to the slides. And of course you had to do that, didn't you? No, where are we? Over to code. All right. So too far. There we go. I want to show you more than a demo. And I wanted to talk to you today about the transcription service I've written. And I love these big processes, these systems. So I quite often just build them. Now, a transcription is a really good thing to farm off to an Azure function because they're time consuming, they're intensive. We're going to use a third-party speech-to-text API, and when you send that off, if you have 30 minutes of audio, it takes 10 minutes to get the transcription back. So that's actually really slow. So you don't want to be worrying about handling the queue or anything like that. You just send that off and our Azure Functions system is going to handle that. So let's go through what this looks like. We have any old app. That can be your monolith, it can be in framework, it can be in a different language altogether, whatever you want, as long as it can make an HTTP request. We're going to upload an audio file, so we'll capture the audio file somehow and we'll upload it, we'll stream it to our trigger. Now this is an HTTP trigger and that's going to take it. And all this does is save it to the blob storage. And then we're going to use a blob trigger, and the blob trigger will come and wait until it sees a new thing has been written to the blob, and then it will go. And then that's going to send off a request to the speech-to-text API. It's also going to write a record to table storage. Now, you may be thinking, why can't the upload do all of that? Well, what we want to do is make sure that each function does just one thing, so it can do that one thing well. Don't be tempted to make your function do too much. It's a real mindset. You want this to be small and concise and easily testable, easy defined units of work. So don't try and cram too much into one function. So once our blob trigger has fired, we are now going to wait for our API, the speech-to-text API, to tell us, hey, your transcription is ready. So we're going to use a webhook. And we can, again, use another HTTP trigger for our webhook. So that's what we've got. And then the webhook will update the table storage with the transcription. So let's go and have a look at this in action. Okay, so this one is just built in .NET Core 3, so Azure Functions 3, I should say. I need to update it to .NET 6, but time. So this one has multiple projects, and this is really important. You can structure your Azure Functions right in with your regular solution. In this case, if I was deploying all of these projects to a web app, I probably would deploy my Azure Functions with them. If I'm already paying for a web app, I may as well have the Azure function on that, and then it will be always on hot start. It won't have that cold start problem, but it will be more expensive. But we'll go into that in a little bit. So I have a Blazor application in here. This is Blazor server, and that's going to capture our audio. And then I have my processor. One thing I didn't mention when we were looking at the other application was that all of these Azure Functions come with a git ignore, and that's really for this line here, because by convention, they have the all your secrets in your settings .json file. You don't want to commit that to Git. So you'll notice here that I have my local settings, and then I have demo settings. You can see it's like set in secrets. Yes, you can use user secrets in here. But you may also notice that I've got the values that came with that. And then outside of that, I have lots of other stuff. You may also notice that, hang on, is that not the same as that? It is. So Azure Functions are very convention-based, and I'll explain that as we go along. Losing my voice now. Okay, so if we go and have a look at our first function, that is going to be our upload function. And you'll notice straight away that I have a constructor, because Azure Functions support dependency injection, which is like, yay, so awesome. You can develop them just like a web app. It's great. So that means you can do all your testing with ease. Everything that you have in a regular web app, you can do in an Azure function. And this is just makes them all the better. So we have a data repository in here. There are a few things you need to do that differ from the other application. You'll notice I have added a startup project, and there's a key to making your function read your startup, and that is this line here, line 19. So to get an Azure function to acknowledge the startup, you have to put this, and this inherits from web jobs. So if we go and look in here, you can see web job startup, okay? So you give it the startup, and then now you inherit from function startup, and you can run. You'll see this looks very similar now. We have our configure. We go and set up some stuff. We add logging. I'm bringing in options. So I've got the options pattern now for everything, for giving myself strongly typed configuration. You can see I'm adding lots of things as singletons, and you're thinking context, shouldn't they be transient or scoped? But these are API driven. They're not, because I use Cosmos DB and blob storage and things like that. They're fine being singletons. And then here, this is the thing that I need just to make sure it's bringing in environment variables. That's your user secrets. This code is all available on my GitHub, so don't worry, you can go and pour through it. So if we go and start this, I think it's easier if we see it in action. So to do this, I need my friend Mike in a mug, different from my other mic. So let's go and start that. Hello, Codecamp Romania. Thank you so much for coming to my talk. Okay, so you can see if I minimize this straight away, we've come in and I've streamed this up, and this is coming from the Blazor application. It just fires off a request here and streams up my audio file. We convert that to array, and we pass it over to our data repository, which then connects to Azure blob storage and saves it. And then that's it. That's all that one does. And now we should hopefully hit the blob trigger. Yes, phew, that took longer than normal. So now we're in the blob trigger. And one thing you'll notice if I come over here is, that one can go. We can have this one, is that I only have the download and upload. There's no blob trigger here. It's not an HTTP request. You can't just make a request to the blob trigger and fire it off. It's convention based. So what we have here is our blob trigger, and it is going to look at this very specific file. It's going to go to the blob storage that we give it in this connection string here, and it's going to look for audio container and then a file that matches this pattern. You'll notice that the ID here, it's not string interpolation. it knows that this is going to be a variable. And if we come along here, you can see we pluck that variable out. And we have a stream, which is my blob, and that will stream the contents of this blob to us. Now, this is where it gets a little bit tricky with the convention. This is looking very specifically at that values container. Now, what I'm going to do is just bring this over here because I'm actually going to show you my local settings. And if I come over here a little bit, I've got actual connection strings in here. So that's why I'm being careful. So you'll see that storage connection string here, set and user secrets, but actually here, it's right there, ready. You could go and look at it if I wasn't careful. And that's because our blob trigger specifically comes and looks in values storage connection string. However, when we go and do our options pattern and all of our dependency injection, and we want to go and get that, it looks outside the values. So that's why there's stuff here. So it is a little bit tricky, and we go and put that. But as long as you know that's what's happening, you'll be okay. So if we come back in here, you can see this is looking in the values, and we come through and we can get our information off this. You can see it's gone and got the ID, and that's plucked off this pattern here. So I'm going to let that go. It's going to fire this off to the speech to text service. It's queued, good, so it's successful. And it's also going to write a record into our table storage. And here we go. I actually, you may be wondering how an external API is calling into me. I'm using ngrok here. So you can see I have that going. Your company may or may not be happy with you using ngrok because it's like a tunnel through your firewall. But I find it a fantastic tool for developing with APIs. So now this has hit my download function, which is an HTTP trigger. And there's a couple of interesting things here as well. Notice this webhook response. That is something I have defined. You can define your own things as a response coming in. And this binds to what I expect to come back from the speech-to-text API. You'll also notice that I'm using Newtonsoft.json. Currently, if you were to use system.text.json, it wouldn't recognize these. So again, convention-based, you have to use the Newtonsoft ones, okay? So as long as you know these things, you'll be okay. So if we just let that run through, and then I come and look at here, I think because I was too slow, it's all gone a little bit funny. But if you come down here, I've made it print my turn. It's going to go again. It doesn't like waiting, okay? And you can see now it's printed it again. It didn't like the wait. And I've actually got it to print what I said into my microphone out for you all. So you can see the whole system working there. And then you do whatever you want with that. So that's like a full system. I have another one that does image processing on my GitHub. I don't know why OneDrive has opened. Does anyone ever know why OneDrive opens? But hey. So I hope that gives you an idea of the kind of systems that you can build and execute with Azure Functions. And that's all without durable functions as well. Durable functions are a whole different level. We're not really going to touch on those today. So let's have a little look about how we architect a solution. And we can see that it can be structured like any .NET web application with your dependency injection, your user secrets. You can have references to external projects, whatever you need to build your application, you can do. And you can use the methods that you're already familiar with. It supports .NET Core's dependency injection, yay! Supports .NET 6, and just try to remember that single responsibility. Your function trigger should do one thing and do that one thing well. I feel like that's my mantra. I say that a lot, but it's a good philosophy in software engineering. So let's have a look at the payment options. We have the consumption plan, which is pay as you go. which is probably what most of you would be using, unless you want to deploy it on a VM that you're already paying for. So you get a monthly free grant of 1 million requests. You get 400,000 gigabytes, and then 15p per 1 million executions. So we are talking very cheap, incredibly cheap. You do have like some storage fees, but storage again is really cheap when you're talking teeny tiny little applications. So all in all, when you're looking at a web application, which could be like, I don't know, $60 a month for a basic web application that doesn't have too much vCPU, very standard. I think the last web app that I hosted for a long time was about $60 a month with my SQL server on there as well. So this is really cheap. Now the premium has Azure Functions, same features and scaling mechanism, which is based on the number of events, but it doesn't have a cold start. Because it's always running, it doesn't have to go and find a server and start it all up. It's already running. So it can, if you've already got a VM up or something, it can be cheaper. Otherwise, you'll build based on the vCPU and the memory that your functions consume. There are some things to be aware of. You get, I think it's around 200 instances on the consumption plan to scale to, and it will automatically scale to 200. When you are using premium, I don't think it goes to either 100 or 150. I've got it written down somewhere. I'll find it, but it doesn't scale to as many. Okay. You can control the scaling as well. You can reduce it. So if you want your consumption plan to only scale to like 50 instances, you can control all of that as well. But straight out of the box, if you don't care and you just want Azure to handle it, it will do it all. You don't need to do any settings. Okay. So we touched briefly on the security and authorization. We had those authorization keys, and we had anonymous function, admin, system, and user. I don't recommend you use those as a way to secure your application in general. They're not very secure. So if you need more trust on your system, I would look at securing your HTTP endpoints. So maybe that's with app service authentication and authorization, or you use Azure API management, or you deploy your function app in isolation. So you have it in a little bubble and it can only talk to other things internally. So you can control that nothing gets into it. Now, Azure API management service is very expensive. I think it's like $1,500 a month starting price. So it really depends on the trust you need in your system. When you deploy in isolation, as of like earlier this year, they enabled Azure Functions to talk to other things in their sort of resource group without any security. So you could have everything in a resource group. I think it's a resource group. I could be wrong on that, but in their little bubble, and they can all talk to each other nice and clearly. So that might be a way if you have your application deployed as a web app and then you have your functions in there. You don't need to secure them. They can all just chit chat without any problem. So an update, I mentioned isolated process. So this was to get you running with .NET 5. And this means that you can decouple your Azure function from the host, and they were very tightly coupled. And this allows you to run .NET 5 and other languages, I believe. Now, Azure Functions 4.0, which came out last month with the release of .NET 6, means that .NET 6 will run in process. It also runs out of process in an isolated instance, but you can do it either or. If you want to do things with durable functions, you absolutely have to be running in process. So you wouldn't be able to use durable functions with .NET 5, for example, because it runs out of process. So those are some really good updates. Now, just to touch on durable functions, I don't really have any information in this talk on them, but people always ask about them. They are more like a pattern, and they will orchestrate a collection of Azure functions. And do I have a link I can show you? So if I come out of here, I just want to show you briefly. Let's have a look at orchestration. Let's have a look at this overview. I just want to give you a quick idea of it. I should maybe put a slide in, but it's these patterns. So why would you want to use a durable function? You want to have like function chaining. You can have them fan out, and then how would you get them all to correlate back in? So you can do all of that as well. Other systems, and you can have them monitoring things. You can have human interaction. So there's quite a few different things that you might want to do, but you can see that you don't have to. The system that I demonstrated for you does everything you want without the need for an orchestrator if you architect it intelligently and you think about the processes that you've got. If you absolutely do need to use a durable function and orchestrate, do know that they are expensive. They are much more expensive than regular functions. So, think about how you're going to architect your system. Can you do it just by using clever triggers, as I have done on my audio processor? So if we come back over here, let me start this up. I've got some further reading for you. Just the general docs is a good place. There's so much information on there. If you want to know a little bit more about the configuration of them, there's a great blog here as well. So from Silicon Orchid, and it's all about configuration. Now, I promised you the review on cold starts, and Michael has done one all on that, and lots of graphs and lots of information on that. Now, isolated processes, as I mentioned, you may or may not want to do that, and there's a lot of information on that there. So I'm trying to see, I've left lots of time for questions, and you don't have any questions. I thought you were all supposed to be giving me questions in return for prizes. So what I'm going to do is come here and show you. Oh my goodness, come on, computer. If you want to see another example of a system, I have one here. Now this one does image processing. Of course, I wouldn't be able to find it. I have a lot of Azure functions on my system here on my GitHub. So feel free to come in and have a look. There are, that's the one we've done. So Blazor Audio Spike is the one we looked at. And then we have, I'll find it eventually. Photo. So this works very similarly. This one, as you can see, is 2 years old, architected quite similarly with the blog trigger function, but this one will go through and process your image. Again, image processing is quite labor intensive, so this is another really good example of a use case for it. What I'll do is I'll drop into the chat. I see Michael Holmes has given me a thing as well. Thank you. Right. I don't know how to, I don't seem to be able to drop in a question into chat. So I'll get the guys to do that in a minute. Okay. I tell you what, I'll put it in the private chat and they can drop them in for you. So there's my GitHub. I also have a link down here for the slides. Okay. And I'll just do that whilst I think of it. Okay, so Michael Holmes has said, when would I use Azure Functions instead of a web API? So that's a really good question. And some people have asked me now with the release of minimal APIs, where does that leave you with serverless? So when if you have a web application, a web API, it's probably because you need a lot more going on. You want to serve up front ends. If you're doing a web API, you're not going to do that, but you're going to serve up a lot of data. You're going to have views, you're going to have authentication, you're going to have identity users. You need that whole infrastructure of an application because you have all of these things you need to do. That would be, you can totally do it with Azure Functions, but you want to ask yourself why. Why would you want to break everything up into small bits and then try and string them all together and have them connecting to each other? Maybe you want to do that, but then you're looking down all of the problems that you have with distributed architecture. And maybe that's the way you want to go. But then you want to think about, if I'm going to do a distributed system, do I want to do it all with Azure Functions, or do I want to do it with like small microservices? How do you go through all of that? So I think typical developer, it depends. You want to be taking small, confined use cases and using Azure Functions for those, in my opinion. You want something that you can fire and forget. You can queue something up. You can use the triggers that are already there, or you have that as a like a queuing system or data connectors. You want it to connect different parts of your application together. And writing a whole application in Azure Functions, you're not going to have a good time, because you will come across all of the pitfalls of distributed systems and it will be hard to maintain. So that's why I say you want small things, small, easy to do things to do it. I hope that ramble has answered your question. So Bogdan has said, for the blob trigger, for example, what is the delivery policy of events? So if you, by delivery policy, do you mean like the failover if things don't go through? I'd have to have a look at that. All of this is generally handled for you by internal queues. The functions just sit on like other systems. It's all under there. So I should think the policy is going to be very similar to if you were using Azure Service Bus and things like that. But there's probably ways that you can configure that failover yourself. I haven't looked into it, but that's a really good thing to go and look into. But it will be in there somewhere. Adrian says, this is one of my favorite topics. I'm using functions as a wrapper for APIs, especially those OAuth based, where a refresh token is needed and many internal parameters to be passed. In terms of architecture, I'll say that Azure Management API is a must to orchestrate the APIs, and also Azure Front Door for an extra level of protection. Yes, Azure Front Door is it's really interesting. The blog here, Silicon Orchid, he actually goes and covers Azure Front Door. If you're interested in that, go through this this configuration thing, and he covers Azure Front Door. That's quite an in-depth thing. So if you are, so going back to Michael's question about when would you use like Azure Functions of Web API, you're going to have to think about how you secure all of these things. You're going to need some kind of gateway to correlate all of the information coming through to them. And then how do you distribute that across them all? Do you use an orchestrator? And I think you just are making more work for yourself. I really do think that they're a complement to other systems. So I hope that makes sense. I'll just pop this up on here. If you want to reach out and chat to me about any of that, you can find me on here and we can carry on with questions. I hope those answered some of your questions at least. And I hope that's made you want to go and try them if you haven't already.
Definitely, thank you. And yeah, thanks for the practical session, really insightful. And as we were going along, I was writing down questions myself, but then you started answering some of them. So
Good.
that's the one, how do you secure an Azure function? And then you touched upon it a bit. Um, Another thing would be, so there was yeah different ways that you can host them. So
Yeah,
that you have the cold start, the warm or hot, and then probably they're on different plans that costs more.
yeah.
Uh, but then what is the trade-off? If it's a cold start, how long of a delay are we looking at?
It's really not that long. It's not something you should worry about in general. If we come and have a look, and the cold starts aren't really a thing now either, because they've always got the pool of workers running. So what are we looking at? They do go back to sleep. That's another reason why you might not want them to be a web API, because they switch off. So they do time out, and I think it's like 20 minutes, and then they're decommissioned. But there's a whole load, as you can see, there's a lot of information in here. I'm just trying to see. There were a lot more charts. He used to have more charts. He must have updated it, but it was something like a couple of seconds. No, PowerShell functions are very slow, 4 to 27 seconds. I mean, that is a long time to wait. So if you needed your PowerShell function to be ready, you're going to want to have that in an actual thing. So we've got 1 to 10 seconds in general. I did read somewhere, I think, that the average was 7 seconds. But if you were doing that from, I don't know, if you had a UI, you'd be looking at having a client-side application that could be showing data or showing something whilst you spin up that function. But this really depends on your use case. Everything is always about your use case. When I'm doing the audio transcription service, what do I care if I'm queuing up these transcriptions and my Azure function has gone to sleep and it takes 7 seconds? We're talking like 10 minutes to do a transcription. I'm not needing an immediate response. So when I fire it off, it can be cold. I don't care. Just go and do it. If you have a user at the other end waiting, then that's where these cold starts may be a problem. And I think that's the consideration you have. But it is expensive if you switch over to the not the premium plan, not the consumption. I was getting consumption pay as you go. No, they're the same. So it can be really expensive if you go that route.
Yeah, makes total sense. By the way, we have different speakers today, but we also have different hosts for our show. So there's
Hi.
Mihaela, and we're gonna have more surprises along the way.
Oh, the surprises. Am I going to miss the surprises then?
With us.
All right, so we ticked that off. What else do we have, Mihaela, on our list?
Well, I was thinking as the title of the presentation was like an intro, getting the grasp maybe of Azure functions. Let's say that I'm a total beginner, and yeah, I get very excited after this presentation, and I want to try it on my project. What are the best practices that I have to take into consideration in order to be sure that what I'm implementing is reliable, and if I really need it, maybe?
So I think you probably need to know why you want to go off and play with a serverless function. If it's just to learn, then that's a hobby. You don't need to worry about its reliability as such for that. Any coding practice that you've learned, any good practices that you've learned in general, you can bring over to Azure Functions. So, separation of concerns, extracting stuff out into smaller methods, making things testable, make sure you use good design patterns. You can use all of that stuff that you've learnt. And then Azure makes them really quite reliable. You push them off there. The whole thing is very managed for you. That's the beauty of Azure Functions. You don't have to worry about commissioning the front ends and, you know, the gateways and the endpoints, whereas on others, you actually have to go and give permission for the gateway to talk to it and the endpoints to come out, and you have to do all this other stuff. So they're not very accessible to a lot of developers unless you have a lot of like DevOps experience. So as a beginner coming in, I think what's really nice is that they're quite self-explanatory. So you can just go and create a new template and you can play straight away, put breakpoints on and see what's happening and learn from the code. And then because they're small, finite little pieces of code, you don't have to worry about, you don't have to do the dependency injection. You don't have to worry about the startup. You can literally just write a little application that does something, you know. So as a beginner, that's a really appealing thing. I have one that's inventory. So this is a simple Azure function. To do is the README. So I built this last year for someone, and it was for their project to get a track jacket at work. And this was literally just to serve up some data from an SMS. And it's, you don't have to go into depth. You don't have to have a lot of infrastructure to do something simple. So if you want to make a small project as a beginner, you want to use a fun API, you want to translate, I don't know, you want to translate your sentence into Klingon or something, you can go and do that without having to worry about this huge amount of infrastructure. I mean, I've got like pirate functions in here. I've done a lot of like a pirate translation function. And this one literally goes off and goes to, this one I switched it over to ICANN has dad joke. So it goes and gets a joke. But I don't have to worry about having a big web application, the overhead of it. So for a beginner, you can have these fun little starter projects for your portfolio. You can have things that just pop up on a static website. So I think they're really an easy way to get into development, if that makes sense. Does that answer your question?
Yeah, I think that if it is to conclude is that we can start with something small and then see how exactly we can evolve in time, depending on the context of our application.
Absolutely. It's like a building block, small building blocks. You don't have to know everything with them. You just need to know a bit of the code rather than this huge infrastructure that's like, why do I need a startup, a programmer, this, a middleware, you know, all of this? And you're like, I just want to make an API get a joke for me because I want to learn how to make HTTP requests. And that's what functions can do.
Thank you.
Yeah, they're really come in handy. Thank you, Layla. Awesome as usual. Thanks a lot for being here again, and then hope to have you back next year.
I would love to. So maybe, who knows, maybe in person might be a thing next year. Who knows?
Just crossed.
Thank you so much for having me. Thank you for the questions, and have a wonderful day, everybody. Bye.